Hello and welcome. So from this video, we will begin with multithreading in Java. Okay, we will see many things, many topics. Introduction to multithreading, the way we define a thread, what is a thread, setting and getting a name of a thread, thread priorities, many different functions in a thread class, synchronization, inter-thread communication. We will see many things. Okay, so let's begin our journey with introduction to multithreading in Java. So before we deep dive into multithreading, tell me what is multitasking. Okay, you have studied it in operating system subject. What is multitasking? Okay, multitasking in a computer. What is multitasking? Just think about it. What is multitasking? Just think. So what is multitasking? It's simple. Operating system ability to have more than one program working at what seems like the same time is known as multitasking. Okay, what we can do many different things in our computer. We can download files. Simultaneously, we can listen to music, correct? Simultaneously, we can write code also in our code editors. Simultaneously, what you can do else? You can send mails, correct? So you can do many different things. So for examples, we can print a document, listen to music, write code, download files all at the same time. This is known as multitasking, correct? There are two types of multitasking. There are two types. What are those two types? Process-based multitasking and thread-based multitasking. Now let's define what is a process-based multitasking and what is a thread-based multitasking. Correct? So you may have an idea of process-based multitasking. We just talked about it. Now we will also define thread-based multitasking. Okay? So difference between process and thread-based multitasking. Let's see. Let's begin. So executing several tasks simultaneously where each task is separate independent process is known as process-based multitasking. So several tasks simultaneously where each task is separate independent process. Correct? Separate independent process. Let's see what this means. So here, as you can see, we will download some files. We will listen to music. Okay, we can write code. We can print. So all these processes are actually independent of each other. They are not dependent upon each other. They are all independent of each other. So executing several tasks simultaneously, they are being performed simultaneously, but there are separate independent processes. So this is known as process-based multitasking. I think it is very clear now. So what is thread-based multitasking? Individual programs will appear to do multiple tasks at the same time. Each task is usually called a thread. So what this means? So for example, we have our program. Okay, suppose it has 100 lines of code. How many lines? 100 lines of code. But the 50 lines of code and these 50 lines of code are not dependent on each other. It is performing a different job and it is performing a different job. So what we can do? We can divide them into threads. So individual program will appear to do multiple tasks at the same time. If it is a single thread, if it is a single job, so what it will happen? So compiler will simply compile it like this. Okay, after 50th line, 51st line will be executed, correct? But now what will happen? We have divided this task into two subtasks, and both those subtasks will be executing simultaneously, and each task is usually called a thread. So it is thread 1 and it is thread 2, and they will be executing simultaneously because these 50 lines are not dependent on these 50 lines, but they are in a individual program. They are in a single individual program. So what was happening here? The programs were different. Okay, we have a music player, we have a browser, we have a printer, so that is performing printing. So these all are different processes. But now what we are doing in a single process, we are dividing the work, and this work is not dependent on each other. Okay, we will see what will happen when this work is dependent on each other, but now this work is not dependent on each other, correct? So each task is usually called a thread. So this is difference between process-based multitasking and thread-based multitasking. Here the processes are different. Here the process is same, but inside that process the tasks are different, and each task is called a thread. Fine, I think it is very clear. Now it is an operating system level, not at programmatic level. As you know, it is operating system level because operating system provides us the base for all these different processes. All these different applications run on operating system, but these are different applications. But at a programmatic level, we have just a single program. Correct? So it is on thread side. So it is at programmatic level. Programs that can run more than one thread at once are said to be multi-threaded. Programs that can run more than one thread at once are said to be multi-threaded, correct? Now each thread is a separate independent task of the same program. I have explained you this line. Each thread is a separate independent task of the same program. Now this is important, of the same program. Okay, I am emphasizing on this again and again. It is the same program. Here it is a separate independent process. Okay, here it is the same program. Inside the same program we have different tasks, but here we have different processes altogether. Okay, next point. The essential difference is that while each process has a complete set of its own variable, threads share the same data. So we will see this point afterwards. Okay, which data threads share, which data thread does not share, we will see this point afterwards. Fine. Now on the some OS, threads are more lightweight than processes. It takes less overhead to create and destroy individual thread than it does to launch a new process. Correct? So I think you have read this line before also somewhere, that threads are more lightweight. Threads are more lightweight. They run on the same memory that is allocated to the program itself, so no new memories need to be allocated to them. Correct? Some of the data is shared, only some data is not shared and some data is shared. We will see this afterwards, which data is shared and which data is not shared. Okay, so it takes less overhead to create and destroy individual threads than it to launch a whole new process. Fine. So these are the differences between process based and thread based. There can be many other differences, but these are the important differences in process based multitasking and thread based multitasking. Now what we will concentrate on in multi-threading, we will concentrate on thread based multitasking. Okay, the process based multitasking, we concentrate this on operating system. As you have known, process scheduling, process management, everything is there. Now we will see thread scheduler also in this. We will see synchronization, we will see inter-thread communication also. So we will be focusing in multi-threading on thread based multitasking. So now let's see what in which areas multi-threading is used. Okay, what is the main objective of multitasking and multi-threading? Okay, in which areas it is used, let's see that. So objective and areas of multi-threading. So whether it is a process or a thread based, the main objective of multitasking is to reduce response time. You might have known this in operating system also, from operating system also. Correct? So the main objective of multi-threading or multitasking is to reduce the response time of the system and to improve the performance. Okay, what it says that CPU should not be idle for a long time. CPU should not be idle for a long time. It says this. So the important areas where multi-threading is used are to develop multimedia graphics, to develop animations, to develop video games, to develop web servers. Now let me give you some examples. So for example, this is a screen. This is a screen. Correct? Here birds are flying, rain is going on, and for example this is water and there is a boat inside the water. Correct? Just don't concentrate on the drawing. Here, these are the birds, these are rains, this is the boat. Okay, so we have many different objects in a same screen, in a similar screen. So if I don't use multi-threading, what will happen? At a time only one object will move. For example, this bird will move and the rest of the screen will be static. Then after this is over, this bird will move and the rest of the screen will be static. If birds are not moving, a single droplet will actually fall and rest of the whole screen will be static. And this boat will move, rest of the whole screen will be static. So I have to use actually a thread for each and everything inside this screen for animations. Okay, a boat will also have a thread, a single bird will have a thread, a single droplet is a thread, okay, of rain, it is a thread. So each thread will move simultaneously, and then we will see this whole screen moving. As we know, birds are flying, raining, boat is moving, everything. Okay, so this is the area of multi-threading. Correct? To develop animations in graphics, in video games also. And what about web servers? So as you know, on a web server, many different applications request arrives, okay, so here also what web servers have multi-threading as a concept. Fine. So this request can be fulfilled simultaneously. So these requests can be fulfilled simultaneously. So these are the areas where multi-threading is used. Okay, now let's look at what are threads. So what are threads? What I have explained you actually. So what do you think a thread is? Okay, there are many different definitions of thread. Okay, you might have known many different definitions of a thread. Okay, so if this is one thread that is moving, and then I can split it into many different threads. This is a single program. Then I split it into T1, T2, T3, T4, T5. There are many different threads. So actually this is a flow of execution of my program. Now I am changing my flow of execution. Okay, and each flow of execution has a different task to perform. So a thread is an independent path of execution within a program. Within a program, it is an independent path of execution. This is a path of execution. Okay, each flow of execution is a thread. and each flow of execution has a separate job to perform. Now this is important. This thread has a separate job to perform, this thread has a separate job to perform, this also has a separate job to perform, and this also has a separate job to perform. Because they have separate jobs to perform, we can perform this job simultaneously using multitasking. Correct? Since they have separate jobs to perform, we can schedule these threads on our CPU in a multitasking manner. Okay, this is done by thread scheduler. We will see that afterwards. Fine. So what is a thread? Thread is nothing but a flow of execution within our program, a flow of execution. Okay, T1 is a different flow of execution, T2 is a different flow of execution. Fine. And each flow of execution has a separate job, to perform. So these are threads. So this was the introduction to multithreading. So what we learned in an introduction to multithreading, the questions that can be asked to you, what do you think? So first is, how many types of multitasking are present? There are two types of multitasking. What is process based and thread based? What is the main difference between process based and thread based multitasking? You can note these questions down. How many types of multitasking? Two types. What is the main difference between process based multitasking and thread based multitasking? What is the areas where multitasking are used? Okay, what is the objective of multitasking? Fine. And what are threads? So these are the questions that can be asked from this video. Now in next we will see how we can define a thread. In the next video we will see how we can define a thread. Okay, thank you.